we've got a gas tube with an electrical field of increasing strength. So here's your gas, and this plate's going to be negative, this plate is going to be positive. And the gas becomes conducting when the electrical field reaches a strength of 35 kilovolts per meter. So that's our electrical field strength in here. Just gets stronger and stronger as the potential difference across it increases. Part BI, calculate the force on an electron in the tube when the electric field strength is 35 kilovolts per meter. And number 2, explain why the gas becomes conducting only when the electrical field strength in the tube reaches a certain value. So, let's jump across. First off, so we've got 4b part I. We know the force on a particle, a charged particle, is EQ. They told us the electrical field strength was 35 times 10 to the 3 volts per meter, and the charge on an electron is 1.60 times 10 to the minus 19 coulombs. Multiply those two together. 35 e to the 3 multiplied by 1.6 e to the minus 19 gives me an answer of 5.6 times 10 to the minus 15, and that'll be newtons. Newtons, because it's just a force. Alright, part 2. So, what's going to be going on? We've got a positively charged plate and we've got a negatively charged plate. And a given particle, let's make it on here, and say it's an electron here, and the stronger the electrical field, the greater the force is going to be, because F is equal to EQ. So you're increasing the electrical field, you are increasing the force of the particle. So what's going to have to happen is in between the two you've got an insulator. So you have to reach a point whereby the force on the particle is enough to actually overcome the insulation properties of the material. Now there's a lot more physics to it, but you don't really need to go into that at A level. So the way I would explain this in A level terms is a spark will occur when the electrical field strength is strong enough to overcome the resistance of the material, of the gas, and i.e. the force becomes great enough. F is equal to EQ. Now, this is actually kind of key in terms of a lot of scenarios. The interesting ones are things like lightning. So this is the sort of process that goes on in terms of lightning, where the atmosphere, charged particles in the atmosphere compared to the Earth, and you'll get lightning moving between them. A lot more fundamental to that is something like a petrol engine in a car. That actually contains a spark plug. And what you do is you set it up so you actually get a spark between 2 points, and that spark causes the ignition in the engine. My favourite version is actually with the Van de Graaff generator. And the Van de Graaff generator, what actually happens is you can give a student an electric shock. So they basically move their finger, for example, closer and closer and closer to the Van de Graaff machine till the distance between the two is small enough, then the electrical field gets strong enough such that the charge can jump across that gap. Thank you very much.